Okay, let's get started. Hello, everyone. Thank you very much for joining us today to today's CNCF webinar, Hybrid Serverless Development Using Quarkus and Kubernetes. I'm Jerry Fallon, and I'll be moderating today's webinar. We would like to welcome our presenter today, Daniel O., Principal Technical Marketing Manager at Red Hat and CNCF Ambassador. Just a few housekeeping items before we get started. During the webinar, you are not able to talk as an attendee. There is a Q&A box at the bottom of your screen. Please feel free to drop in your questions in there, and we'll get to as many as we can at the end. This is an official webinar of the CNCF, and as such is subject to the CNCF Code of Conduct. Please do not add anything to the chat or questions that would be in violation of the Code of Conduct. Please be respectful of your fellow participants and presenters. Please also note that the recording and slides will be available later today on the CNCF webinar page at cncf.io/webinars. With that, I'll hand it off to Daniel for today's presentation. Take it away.
Thanks, Jerry. Yeah, hello everybody, and welcome to joining CNCF webinar. So let me kick it off the cool video first here. So. Okay, so what a fantastic video to wake up our new webinar, and so maybe you can remind how the Java was born and how to get started and how it was developed in the last decades ago. So actually this year is a 25 years anniversary of a Java application. So there are a lot of changes. Maybe you people already playing with the Java application development. Okay, so let's jump in. Today's topic, hybrid serverless development using Quarkus and Kubernetes. So my name is Daniel O. I'm working for Red Hat as a technical marketing major with a specialized cloud-enabled application development as well as Agile and DevOps practice. And Jerry already mentioned that I am CNCF ambassador, also DevOps ambassador, in order to evangelize the cloud-enabled application architecture references and development practice with along with the DevOps initiative. And then I want to encourage you all guys to subscribe my YouTube channel, the me Daniel O TV, and then you gotta find a lot of technical demo and the technical tips and the interesting, even non-technical, interesting tutorials. Okay, you can also follow my Twitter, and I recently published my answerable book. Maybe if you are interested as a reviewer, just let me know by Twitter or my YouTube channel. All right, move on. So just take a step, just one step back and take a look at that, why we needed to Quarkus to develop the hybrid serverless application with the Kubernetes cluster. So just take a look at that. Back in 1995, Java was born and unleashed upon the world. And at a time, most of the developers really love to use C or C++ rather than Java. But we have such a great change around the world, like internet technology came up, and then the Java was really fitting in that technology. And then after a couple more years later, so all enterprise company is totally changed their infrastructure layer and also software layer to maintain and run their business application for the end users. So here are just some example to spin up your Java application to serve your business capability on your customer or end user customers. So first of all, almost $463,000 at a first time to buy software, hardware, and specific middleware, etc., to all spin of your Java application. As well as, but also you needed to, in a project company perspective, they needed to spend more than $80,000 every single year to maintain software, hardware, etc. But this is actually happened and 25 years ago. And then just a little bit narrowed down an enterprise architecture point of view, we just only one application architecture, also known as a monolithic application. So main priority of a monolithic application, just running a lot of the application, but sometimes the 5 application or 4 application running on multiple app server based on high availability architecture, maybe 2 app replication or 3 application on multiple virtual machines, sometimes the bare metal. And then if you want to change your business functionality or even bug fix, you need to waiting for maybe 2 months or 1 month, because the first priority the application server is scalability and the reliability rather than some frequent build and deployment like a CI/CD. In the meantime, we have such a great open source technology and also public cloud to serve a lot of great technology to many enterprise companies. So just for example, back in 2006, the Amazon, first of all, served the public instance, which means many companies don't need to worry about purchase new hardware and maintain that. Just I already mentioned earlier, yeah, so they don't need to spend $80,000 every single year because they just buy and just consume resources from public cloud provider like Amazon, and then just need to pay for that like a pay-as-you-go policy. And also 2009, the huge change of a Java enterprise application. I've been there, so I actually enterprise Java developer and architect in 2009. I spent a lot of time to develop business application like a CRUD and a data integration and integration external server, etc. And after a couple more years later, and then the Linux container was born and the Kubernetes born. It's a totally game changer as an infrastructure layer. So now microservices plus container like a Docker and OCI image format and a Kubernetes, also known as immutable infrastructure, is totally changing your mind. I mean, how to optimize your application, how to make it reliable, how to make it scalable, how to make it faster and high performance on top of that. So now, we enterprise companies don't worry about the purchasing infrastructure, but they really more prefer to use managed service rather than manageable service. So as you described, the Amazon, Google, Microsoft, and a lot of companies already provide managed service, and then customer just go to that public service and pick up the whatever they need. For example, I just need to storage. I just need to memory and CPU based on T-shirt size condition, and after that, just needed to pay for that hourly, weekly, or monthly. This is the changing trend how to maintain your infrastructure layer. In the end, how to run your application. So in this trend, so we need to think about, okay, small application and more efficient application with a less memory footprint and a small size of the application, which means the low bandwidth or network traffic is more, it's gonna be reduce your cost of money. So that's why this is a new trend to consider new application, not only Java, but also the other application program framework like a Go, Python, Node.js, and BirdX, etc. So just take a look at that, the architecture standpoint in the cloud Java application stack. So architecture is evolving to microservice architecture, which means you can run single application functionality on top of the single runtime, like a Spring Boot and Node.js and JavaScript and X and even .NET Core, etc. And the lifecycle pretty much is shortened. So now we can deploy maybe every single day or twice a week, and pretty much faster than a monolithic application because we have some kind of such a continuous integration, continuous deployment, or delivery tool like Jenkins and Tecton and Circle CI. There are a lot of practical, great CI/CD tool make it happen. And memory footprint pretty much less than like 100 or 1200, 300 megabyte with a memory footprint, and then you just need to few seconds to start up your application. But problem is, as you see, the center piece of this architecture, dynamic application framework and app server, and on top of JVM, is totally same thing on your Java space. So let's try to understand how Java is developed and then why we need to use that for developing a business application and to serve World Wide Web, also known as internet technology. So Java was designed for high footprint and network footprint. And then, which means the first priority of a Java application, you need to serve your application all the time and with a high performance rather than big machine or the high cost to maintain your hardware or a multiple layer. So, and also the Java also was designed for a long running process. Nobody care about how many memory and how many hardware you need to prepare to run this long running process. But they just really care about, specifically IT operation team, they really are interested about how many times this application have some error or exception or some kind of security problem. So generally, the long-running Java process application can be running all the time, like maybe 24/7 or 365, except for security patch or bug fix, critical issue, or even operating system patch. But without that case, your application, the enterprise Java application can be running all the time, like a 24/7. But problem is, it's a huge expense. So you have to pay lots of money to maintain this long running process. And also, Java is based on the dynamic behavior characteristic to run the Java application on mutable system, like a just static web server or virtual machine. So if you have more resource to run your Java application, we just need to one more CPU, well, just scale of CPU, or need to more memory resources to make it stable. That's the dynamic behavior, because from a dynamic behavior standpoint, so Java is the running on Java. Based on Java application, you can just compile your source code source code, also known as the bytecode, and then immediate code, and then you can run that bytecode any app server on the internet. So this is, and then during the runtime, your Java application, there are a lot of tasks needed to be done behind the scene. Let me talk a little bit about that thing just a little bit later. But this dynamic behavior really awesome, because when you create your Java application and compile bytecode, and then you can run any application server, which means there's no rocking middleware or app server. You can buy any app server from any vendors, any open source project, tools, etc. But just imagine, we changed our runtime infrastructure layer, like an immutable infrastructure layer, such as Kubernetes and OpenShift container platform by Red Hat. So same application, even single one microservice application, one compile, and then you need to scale out 1,000 container as a pod on Kubernetes cluster, which means when you run your Java application, the Java needed to have some the dynamic task at runtime behind the scene, but when you scale out 1,000 container, which means you have to dynamic task it 1,000 times. It's not a productive way. So that's why people, okay, Java can be heavyweight and run container platform like a Kubernetes. So why this is happening? Now let me explain the truth of Java plus container technology. As you know, Java was born for Unix container technology or Kubernetes technology. So that's why Java really focused on World Wide Web internet technology rather than immutable infrastructure. So needed to long running process and some memory, some little bit large memory footprint and to start up. So that's why we spend maybe a couple more seconds, even 30 seconds to start up the Java application. But Node.js and Go pretty much better than. It's a pretty lightweight and a small memory footprint. As you see here, the red box is your Kubernetes container platform. And the blue box is just one worker node. Each worker node has same resource density, but you can see there are only 4 parts of a Java application can be running on one worker node, but Node.js made 8, and then Go is maybe 24, is 2 times, 3 times, which means the Go and Node.js a small size application and a pretty fast and also small memory footprint rather than Java. So this is another reason why a lot of developers really prefer to develop the serverless application and running on top of the serverless platform, such as Amazon Lambda. So New Relic survey this metric just already at the beginning of this year. So you can see only 60% Java application was taken for the language used on Amazon Lambda. Because we already learned about the Java of hidden truth, so a lot of memory footprint and dynamic behavior and long learning process is definitely does not fit in serverless, even Kubernetes cluster or the optimization perspective. And let's take a look at that serverless landscape. This came from CNCF. So you can see there are a lot of boxes in there. So there are a lot of tools, framework, and manage the platform and a manageable platform. You can install your own manageable platform like an on-prem system. So the question is which tool, which framework, and which platform would be perfect to my serverless application. Even IT operation team or DevOps team, okay, they need to make a choice, the best tool, best framework, and best platform to manage the traditional microservice application as well as serverless application at the same time. So the result is, too many choices. So we need to something different thing, but in the meantime, Java actually has to try to a lot of effort and some time, spend a lot of time and effort to make it better, even try to evolve to catch up the new IT trend and technology. So for example, try to optimize the Java runtime based on Linux container packaging technology, try to reduce memory utilization or CPU utilization, also create a new garbage collector mechanism like Shannon Doha, and also make a distribute the different type of operating system like Android OS based on Dalvik system. So there are lots of effort and some evolving projects that was happen, but still that's not good enough. So we need more something different to make Java make the Java greater along with the container technology and Kubernetes technology. So Quarkus was born just 1.5 years ago. The Quarkus is open source Java stack to create and develop cloud-native microservice application and develop serverless application along with the Kubernetes cluster. And sometimes you can build up very easily event-driven application on top of that. So how it works? Let me explain that very quickly. So Quarkus is optimizing this step. So we just limited the dynamic behavior, but still you can use the same Java application, same Java capability, but we just removed that thing. And so now we just follow the microservice architecture, but you can deploy the traditional microservice application to long running process as well as serverless application. In the life cycle, maybe sometimes just a millisecond, and still you could deploy maybe just one per day or just twice a week, just like your CI/CD pipeline strategy. Also, startup time pretty much faster than like sometimes a millisecond. Let me show you in demo quickly, just a little bit later. And then the memory footprint is pretty much small, pretty much less than. So this is how the traditional Java framework is doing. So in a build step, you can just create a bytecode after your packaging tool like a Maven Gradle. And then when you run your Java application on top of the middleware or just using Java command line, so there are a lot of steps to do under the hood. So first of all, the Java try to load the configuration all file and I'll try to parse them. Okay, this is the dev environment configuration. Maybe this is we don't need it to at runtime because we use the lazy comparison strategy, and also try to load classes and enable, disable some feature, and also scanning annotation and parsing descriptor, etc., etc. And then last step, try to start the actual application like a thread and a pool. So how Quarkus to make it different? So as you see, we just shift all required that thing to the left. So now you can see the Quarkus try to that at the build time, all required tasks is created bytecode and the loading file and the scanning and the parsing and the packaging. We can do that at build time. And also there are two options. You can package your application. First of all, just make it a thin jar like a jar file, and the other one is a native executable file like a Go program. You can run directly your executable file and running on GraalVM rather than JVM based on ahead of time strategy comparison strategy. So now when you see the runtime environment, we just run this application. So this is a native comparison. So first of all, we can create a thin jar and then provisioning and curate, and then you could have two choices. You can create a native comparison, or you can also create a native comparison and create a native executable file and then just run it on. And also the serverless standpoint, Quarkus provide the funky annotation. So funky extension. Extension is part of the capability of Java capability for such as data transaction or less exposure, and then messaging integration and cloud integration, and also monitoring observation integration. All capability is we can call that Quarkus extension. Once you add Quarkus extension, you can see some Maven dependency on your Maven project. I'm gonna show you in a live demo very quickly, just a little bit later. So here is the funky extension to make a Java standard portable API. In the end, the Java developer can create the simple function and then deploy multiple fast and serverless platform such as Amazon Lambda, Azure Function, and Google Cloud Platform with a function. So this is the way the Quarkus how to enable Java developer to develop a serverless application, but still there's no learning curve to catch up new serverless technology. All right, so I'm gonna stop talking here and let's try to jump in how it works. This Quarkus make it easier to develop the serverless application. So I'm going to stop my presentation mode here and I'll switch back to my local environment ID tool. So the wonderful beauty of the Quarkus framework, the Quarkus provide the Quarkus tool as the extension for multiple IDs tool, like a VS Code, just like mine, or the IntelliJ, or Eclipse, or NetBeans. You can just install or add a plugin or extension of Quarkus tool on your VS Code or on your ID tool. And then you can easily create a Quarkus project. So let's try to create a Quarkus project. And I'm gonna pick it up Maven and Gradle. For today, I'm gonna just add a Maven, and you can set up your group ID and also artifact ID. And then I'm gonna just leave all default variable today. So this is the project versioning name, and my project name is Daniel. And then so resource name, the Quarkus provides CDI capability as well as a REST endpoint capability by default. That's why there are one resource file will be generated automatically. So just name is create a resource here. And then I'm not gonna pick any extension at this moment, and I'm gonna save this file in my temp directory. Now you can see here, so POM XML, so you can see some of the dependency automatically generated here, pull down, REST EG, and unit test. And if you don't need some specific dependency, for example, the Qt is one of the temporary generator for your front-end application development. So we're not going to use this one. So I'm going to remove that and go to source file, and the one Java file grid resource generate automatically here. So maybe I'm going to make it bigger for you all attendees here. So as you see, just a hello world example. So endpoint hello and return hello. That's pretty simple. So now I am Java developer, let's say, and then I needed to develop new function, but for that, I needed to make sure this application totally working. So let's try to open new terminal here. And just to run this application using Maven plugin. So Maven, Quarkus, and dev. So this command line is a Maven plugin, but you can run Quarkus application as a development mode for developer. Once you run your application, you will see live coding activated, and also the install features is a CDI bin, REST EG. This is a default feature by Quarkus. This is an awesome feature for developer because the CDI bin, REST EG, the required functionality to develop your modern microservice application. What does that mean, the live coding? I'm going to show you that thing very quickly. So I'm going to spare my terminal window, and let's try to access the endpoint here. Hello. And now we have the return hello as we expected. So let's try to hello. What about welcome CNCF webinar? And I just save my file, and let's try to invoke endpoint one more time. Now we have the result here. Welcome CNCF webinar here, but the Quarkus automatically had to replace my application, which means the developer doesn't need to rebuild, repackaging, and redeploy and restart my runtime environment. Quarkus auto-wired and make it happen for developer automatically, magically. This is what live coding means exactly. In the end, this is a maybe boring task for every single time you change your code, but this is a mandatory task when you develop your application. It's happening every single day for developer the daily life. So in the end, this feature will increase the developer's productivity, specifically working from home, even working in your company. All right. So I just changed the return code. Maybe some people will be curious about, if I add a new Java class, even new method, new class, is this still working automatically, auto wire and the redeploy rerunning without any stop, any manual stop? Let me show you that thing. So I'm going to develop new function and new microservice method here. In order to, let's try to add a new CDI bin here. I'm going to add a new file, greater service Java file. And then this is a class, and I'm going to add, this is the application scope, Java beans. So one single method, just the greeting and with some parameter, like just name. And I'm going to add return code as the, let's say, welcome, and then the name, and then just like hybrid serverless development using Quarkus. That's it, just simple. I just pass down parameter and put in my return code, and then go back to resource file. And first thing I needed to inject my CDI bin here, create a service, and then just service here, and then I'm going to create a new one, just copy existing one, make it faster here. And then, but I need to differentiate the endpoint path here, like a greeting, and I need to dynamically mapping my parameter like a name, and change the method name like a greeting, and mapping the pet parameter here. Just the easiest way to make a good readability. I'm just using the same name here. And I'm not gonna return the static code here, but I'm gonna invoke my CDI bin service and greeting. That's all. So just to recap, I just added a new endpoint method, and using the CDI bin, I just created a new class here. And then let's try to existing application. I mean, the hello. So the same return, and then try to new endpoint greeting, and then make a parameter like my name is Daniel O. Okay, greeting. Oh yeah, this is a typo. Find out, and then let's try it one more time. Okay, now we hello Daniel O, and hybrid serverless development using Quarkus. Pretty cool. I don't even rebuild, repackaging, redeploy, and restart my application runtime, but still this totally working on my local machine. That's pretty awesome. So what are you gonna do next? Now I'm gonna do packaging. I'm gonna start my live encoding, and I'm gonna packaging my application, and I'm gonna skip the unit test here because Quarkus already include the unit test based on JUnit by default, and then the generated the test scenario is expected return code hello. But as already we just changed that something like the welcome CNCF webinar. So in reality, you have to add or modify the generated test scenario along with your application. But in this demo, I'm going to skip that, and I'm going to run my application using Java command, the Java and in a target directory and a hybrid, and run a Java file. But for that, so I'm going to open my activity monitor in this my local machine, and there are CPU memory utilization, and go to memory and just try to check it out how many JVM is running on my local. And actually I have a lot of JVM. I didn't even know that. Okay, so just take a look at here, the last one, 203 megabyte of JVM, and the other one 60. And then go back to ID tool and just try to run this application. So one thing you need to take a look at that here is so just 0.9 seconds. Maybe this is a little bit slower at the first time running. So maybe I'm going to stop, and I'm going to run one more time. So now you can see just 0.8 seconds to start up, pretty much faster than any other existing Java framework, because you already know maybe Spring Boot and the other Java stack takes up maybe 2 and 3 seconds, even 5 seconds to start up, but this is under 1 second. And then try to access the endpoint. So same result, which means this application totally working after I packaging FinJar rather than FetchJar, because then you can see target directory, and then we just need to here just 227 kilobytes. This is a FinJar, and then go back to memory activator, and now we have here 118 or just more than 100 megabytes as a memory footprint. Just remember this number, because I'm going to show you very fantastic stuff. So go back to here, and I'm going to stop. And then what is going to be next step to deploy this application as a serverless? So first of all, on top of the Kubernetes stuff, you need to packaging your application like a Linux container using the Docker CLI, or using zip command line, zip Google container tool, or some push the S2I build. There are multiple choices to containerize this application and push this container image in an external registry. So I already make that happen, but there are two options I already mentioned. You can package your application as a job file or executable file. Let's try to make an executable file here. And one thing you need to do, just using a native compilation profile. If you want to go to Palm XML, you can see here profile native, and then in this profile, create your application after make the FinJar, and then try to create the new executable file, just like a container image. So all necessary dependency is already packaging in this one single executable file. That's why the packaging time takes a little bit longer than the general Maven packaging, create the FinJar, but it's not too much long, maybe just a few minutes, but definitely depends on the size, how the complexity your application you developed. And once you create the new executable file, you don't need to JVM to run this application any longer. So then after that, we're going to containerize this application using Docker CLI, etc. But I'm going to skip that thing, just save time today, because I already packaging this application using Docker CLI, and I'm going to push that image my Docker Hub and Quay.io for as an external container registry. So we just finished that and go to this target directory. Again, we have the new executable file here. The how to run it, just target and just run file like a shell script or a batch file in a Windows system, like a Go program language, like your Linux operating system. And now we can see, and one thing, awesome thing is, we just need 25 milliseconds to start up. Exactly same application. When you try to start up second time, it'll be a little bit faster. So 20 milliseconds to start up this application. So as you see, I told you just 0.8 seconds is really fast than any other Java application stack. But now we have 20 milliseconds, which means almost, yeah, maybe 50 times faster than existing application, Java application. What about the memory proofreading? So go back to here and then try to find a runner. Now we have 8.2 megabytes. Previously, same application, 120, but now 8 is almost 25, yeah, almost 12 times less than memory footprint, and 30 times, 20 times faster than startup. So this is the reason why the Quarkus make the change, the truth of Java, and then more and more Java developers have a choice to develop microservice application based on Quarkus, and then just change it to that microservice application as a function and then deploy multiple serverless platform. Okay, so I'm gonna and just one more thing. So just make sure this native executable file is working as a function standpoint. So try to access endpoint. Yeah, you got the same result here. All right, I'm gonna stop the runtime here and go to Kubernetes cluster. So here's my Kubernetes cluster based on OpenShift container platform. And let's try to new project here. Let's say hybrid serverless, something like that. And then I'm gonna pull down my container image. I already push that thing just before this webinar. And then one thing you need to do, deploy this application as serverless on OpenShift container platform. Just click on Knative service. This is automatically deploy your microservice application as a Knative service, which means just like you have serverless capability. And once you click on that, and then your application is already almost running, and you go to load. Okay, I need just 60 milliseconds to start up. Go back to the topology view. Okay, so already your container is already up. Ooh, super fast. And then click on the route URL, and then you can see the landing page or the Quarkus. You can find some resources, how to get started, how to set up your ID tool. And let's try to access endpoint. Hello, and then we got so same result that we got the end user, and also you can maybe differentiate because in reality you can deploy multiple pod using multiple runtime, and then maybe sometimes okay, I need to make him differentiate my runtime. Need to find out easily where is my Quarkus application. So here you can add actually a label here. So for example, at OpenShift.io/runtime equal Quarkus. And now you can see this is a Quarkus application. And then this application automatically goes down, scale down to 0, just like the expected serverless capability in 30 seconds. This is a default time. Maybe you can change that, the configuration, maybe 1 minute with 20 seconds and 1 second. In the meantime, if there's no any demand or request on your application, that pod will be down automatically, just like a serverless. All right. So let's give to a little bit moment. Okay, just server is just down. This application is just down, and I'm gonna resize my ID tool here, and try to run this application. But in order to do that, I need to copy the route URL. I'm not gonna run my local endpoint here. Oh, maybe I needed to do one more thing before move on, deploy this application. So because in my application, so I'm gonna change this application as a function because I already packaging that feature. So let's try to do that. So in order to make it this application as a function, so I needed to add a new extension here. Just like you mentioned, funky, there are multiple funky extension, funky HTTP binding, and I'm gonna add a new extension here. And then I'm gonna run Quarkus application once again here. And one thing I needed to that just using funky annotation here. So for example, I'm gonna delete here a new annotation funq, and when you use a funq annotation, the function name will be same as your method name. So in this case, your function name is hello. But sometimes, okay, I need to different a name when you use a function. So you can actually do that. like a name, let's say hybrid, and also you don't need to get method because the function use the path method by default and automatically map to your parameter, and then you don't need to pass any longer. And I needed to delete unneeded to packaging file here. All right, so pretty simple. Even your application REST code is pretty simple. And then I just try to access endpoint to make sure like a hello endpoint here. So now you're seeing ambassador, and then we need to try to endpoint new function like a hybrid. So my name is Dan O, and then pass down this the parameter name, and the endpoint is hybrid. And now we have the result that, hey, welcome Dano, hybrid serverless development using Quarkus. So I just exactly packaging application with this snapshot and pushing my container registry. So we already deploy application on the Kubernetes cluster, such as Open Container Platform, and go back to here. I'm going to copy route URL and then change this endpoint and endpoint hybrid and HTTP and endpoint URL, and then make it a little bit bigger and go top and make resize my application. All right, so I'm ready, and let's try to invoke endpoint, and then what happened next. And once you run your application, as you see, your pod is automatically goes up super fast, just like 1 second. And then you got the same result here. Welcome Dano, hybrid serverless development with Quarkus is the same result. So just imagine some application can be start up maybe 5 seconds or even 10 seconds. So that application definitely doesn't fit in a serverless application. Just like the new release of a result. That's why a lot of developers really prefer to use Node.js Go, super fast startup. But now Quarkus, totally game changer. So now using Quarkus application on Kubernetes and serverless environment, you can have the same benefit, but also you can still develop the same Java interface, which means you don't need to run any new technology. Okay, I need to run, I don't need to run Node.js or Go or Python to develop same business functionality for serverless. Still same application, but change that thing. So I'm going to show you one more thing today. So go back to ID2 here. And then back to here. And I'm going to close the terminal window and then start my dev environment. So let's try to deploy the same application without code change into another serverless platform such as Amazon Lambda. So in order to that, let's try to add a new extension, Quarkus extension here, and a funky extension. You can see here the Amazon Lambda extension, and then you can just add that thing, and automatically will be pulled down necessary dependency on your Maven project. And then just one thing you need to do to deploy Amazon Lambda, you need to define your specific function name here. So you know that the Quarkus funky export, let's try to hybrid the function name here. And then let's try to Maven package it, and I'm going to skip unit test here. If you already have some experience to deploy your Java application to Amazon Lambda, you need to use some Amazon command line and some configuration, etc. So once you package your application and go to target territory, all you need to deploy this application into Amazon Lambda is already there, like the bash script, all including the Amazon Lambda command line, like Amazon Lambda, etc. And also, if you want to test this application on your local machine, and there are YAML file based on the same command line here. So I'm not going to test my local machine. I just try to deploy Amazon Lambda directly. So this is the Amazon Lambda, the function, and then there's no the function here. But in order to deploy Amazon Lambda, you need to create your own the load file to make sure. To do that, just make sure, okay, I already created Amazon Lambda load here, and I just need to load resource name to deploy my application as a function and go back to Lambda, and there's no function name. Okay, just using the bash script here, just define your resource name here. And this is my resource name. And go back to here, and then just run manage script file and create. It takes just a couple of seconds to deploy your application in general, and then you can find the result here just in a few seconds here. Okay, we got a successful return. And then go back to Amazon Lambda console, and then now you got to the hybrid cloud is already deployed. And let's try to test this application. So configure application. The name is greeting, such like that. And I'm gonna be changing my name like a Daniel Paul, and save file, test it. And then once you deploy, now you can see the same result but different parameter variable here. So this is a really cool way. And once you testing, or even you don't need to any longer this application, you just need to delete the application with the same command line and go back here. It's already gone. And if you change your, for example, okay, I'm gonna change different function name, and you need to Maven package it once again. But in the meantime, your managed bash script is already deleted and regenerated. So you can also add your resource name once again, or you can just add the resource name as a parameter in your manage when you run the bash script file here. Create it here. And it will take in a few seconds. Okay, we got here successful, and just reload application. So the application function is deployed, and create a test event, record just hello. And there's no parameter actually. So just create that thing and test, and then process this event. And now we got here, welcome CNCF webinar. So now I don't need it to this application any longer, which means you just delete, save your money, and function here, let's go. Yeah. So this is I prepared for the today demo. I'm gonna just recap the today webinar. So Red Hat runtimes actually fully support the Quarkus environment, as well as multiple cloud-native runtime like Spring Boot, Node.js, BookX, and etc. And also there are in-memory data grid, and a messaging broker, and a single sign-on. This is all piece of your cloud-native application architecture. If you're more interested about the Quarkus development, here is the couple more short URL. So there are IDC Quarkus study. The IDC published this report. You can find that some performance comparison between Quarkus and the different Java stack. And also there are bin URL. Try to Quarkus. You can just go to this URL with your web browser, and then there are interactive self experience, hands-on running portal. There are lots of scenarios you can run it, maybe 10 minutes, 50 minutes for each scenario. In a project generator called Quarkus.io, you can actually use the Quarkus tool just like I did in my VS Code, but also you can go to this website and then just click on whatever you need as a dependency or extension, and just click on that and generate your project, and then you can just download a G file and extract that file and just import your ID tool. All right, yeah, I think I'm done. And if there are any question and it's your time, ask me. Or you can just follow my Twitter or subscribe my YouTube channel and just add your comment and question, whatever you are interested about this agenda.
Thank you very much, Daniel, for that wonderful presentation. We are out of time, unfortunately, for questions. Thank you very much for your presentation today and for everyone for attending. Have a wonderful rest of your day and have a wonderful weekend.
Thank you, everybody.